Continuing on looking at the second half of Chapter 2, I'd like to briefly go over some of the details at the very end of the chapter that deal with manipulating strings, which is a very useful thing that you can do that you'll find that will be important for many applications in Java, and one aspect of user output that is called formatted printing or formatted output. To briefly review what the string class is, it's not a primitive, so it's not exactly like an int or a double, but Java allows us to treat it a little bit like a primitive in how we can declare it, for example, in some of the ways we can use it. But there is no primitive data type in Java that holds a bunch of characters. The characters themselves are primitives. So once we want to start dealing with groups of characters together, then we use kind of the power of object-oriented, the power of the way Java can build structures out of smaller structures. By giving us a class that can that has data, which is the series of characters, plus some routines, some methods, which allow us to manipulate those characters. And that in Java, that class is the string class. It's in the standard library, so it's one of those classes that you actually do not have to import. You've seen for the keyboard input and for other things, we've had to import class libraries in order to get access to some useful classes. Well, in this case, it's part of the standard library, so it's already imported. Because it's used so frequently, there's no reason to expect the user to have to import it. Of course, to use a string, you have to create it, and we are allowed to create it just like we create primitives by having a statement like this, which is a declaration, and all declarations work the same way. We have a type, which is string, and we have the name of our variable, which in this case here is number. Okay, so that's going to come up over and over again. When you see a declaration, there are two parts of it here. We have the type, and then we have the variable. The variable is created, and it's created as a certain type. In this case, a variable named number is created, and it is a string. Because string is a class and not a primitive type, it's capitalized just like all classes in Java. Now here's a kind of fine point that's very important in understanding computers. So we include it here because this is a beginning class, but you should really understand how things are going on behind the scenes a little bit. We talked about storing, and we talked about the space that variables take up in memory just a little bit in class. Primitive variables actually contain the value that has been assigned into them. So when we create a variable, let's say it's an int, that's called number, and we assign 25 into it, then there's a memory location that number refers to that has the value 25. It'll be stored, of course, in binary, but it's stored in a memory location that we have associated with the variable name number. And often we represent these things as boxes. So you've got, when you think of a memory location, or you think of the variable that is associated with the memory location, you think of 25 in one box somewhere, and we use number to find that box. We use the name number to look for and find that box so that we can see what the value is in the box. Okay, so this is just a visual representation that helps us kind of remember how computers store the information that's in a variable. But in contrast to that, in contrast to the way that primitive data types are stored, objects aren't stored in variables. Objects have too much information to be stored in one variable, and it actually is organized in a very important way. And objects also have functionality, like methods that are used to manipulate that data. So there's a whole bunch more to objects than there is just to one primitive variable. So they're not stored the same way. However, we do use variables to reference the object, to refer to the object. So in this previous example, when we say string number, number refers to a string, and in many cases it can be treated like a primitive, but the string is not actually stored in a memory location that is referred to by number. It's a little bit different than that. So when a variable references an object, it helps the compiler find the information, but it contains the memory address of the object's location. That's how it helps the compiler find the information. Okay? So we have a visual representation of what we mean. So let's say we have this line here. We're declaring name to be a string, and we're actually assigning a particular name, Joe Mahoney, into that string. This is what that looks like. Instead of having the name Joe Mahoney inside of the box that name refers to, we have some address that points to some other place in memory where the string object is stored. That might be a little confusing because it seems like, well, why not just store Joe Mahoney in here instead of storing an address? Well, the reason is the address is like an int. The address is a single number that can refer to different places all over memory. And an address is easy to fit in one of these boxes, while we cannot actually fit the whole name in this box. And that's why we do this way. So that's a little bit behind the scenes. It may not be super important for you to worry about that if it seemed a little bit obscure. You can go over it again, see if it makes more sense if you listen to it again or think about it a little bit more. But I'd like to go on to talk a little bit more about practical matters in programming in Java, which is how you use a string. So to use it, of course, first you have to create it, and you create it by declaring it, but then you can also fill it with using a string literal. So we've seen numeric literals. 25, for instance, is an int literal. It's you can just put 25 in your program when you want the number 25. A string literal is delimited by quotes, like this, like the word hello. Once you've created a string literal, it can be, you've seen that you can just print out a string literal right to the console, but you can also assign a string literal into a string variable, which is actually a string object. Okay? So there are actually multiple ways to create a string because strings are objects. We've got the convenient way to create strings that is just like primitives are created. Java allows us to do that even though strings are objects. Or we can create it like we create other objects. You'll notice in Java, when we create objects, you're going to see something that looks more like this. So we can declare the variable value and create it as a string object. So we put the type here, which is string, which is a class, and then we say we want a variable to represent an object of that class. So type string, the name of the variable is value, and that creates a space for the object. But then we have to actually create the object, and we do that by using the keyword new. And then we have to, when we new an object, we have to tell it what kind of an object it is we want. I know it seems like it's a little bit redundant because we're doing it on both sides here, but that's because we're actually doing two separate things on the either side of this assignment statement. On this side, we're actually allocating the space for the address here. In other words, we're saying make an address to hold the location of a string object. We're asking the compiler to make that space for us. And then on this side, we're saying Okay, now make a string object, make a new string object, and put the data hello into it. And then finally, assign that string object to the address that we created when we created this variable. So you can see actually two things are happening on either side, and then the third thing is happening when we make the assignment. So that's part of why it's kind of important to understand what's going on here. And then it sort of makes a little bit more sense as to why so much is happening here and why this is a little bit repetitive. Now, because strings are used so often, somebody out there probably agreed, yeah, this is a little bit too much to go through for creating strings all the time. So they allow us to use this shortcut. So you can create strings in the similar manner that you create primitives. A benefit to having strings as objects is that, like all Java objects, they are allowed to have both data and methods that act on that data. This is an idea that we're going to see when we talk more about classes and objects. In object-oriented design, we couple together data and methods because it makes sense to do so, because there are some methods that we find very useful to manipulate the data. So instead of having just a bunch of methods and a bunch of data, as programs get bigger and bigger and it's not clear what works with what we do is we contain these things, or we group these things together into classes and objects so that the methods that work on certain data are part of an object that is a unit. In any case, string has methods because string is a class, is a Java class that's for manipulating strings. One of those methods that we find very useful with strings, especially when we're manipulating them, is the length method. So for any string, so let's look at the right side of this statement here. For any string, like the string called value here, we can use the dot notation to call that object's length method. So in other words, every time you create a string, it's an object, and that object has a length method in it. You never see the length method because you didn't write the string class. But by creating a string object, you have access to the length method. And when you call the length method, it returns a number. So the integer that it returns can be assigned into another variable if you want. It can be printed to the screen. You can find the length of any string, and you can use that length information however you like. And we'll see how the length method is useful in later programming assignments. But that's not the only method that exists in the string object. There are others. You can check the reference to find out what they are. One thing that's important to know is that string objects themselves are immutable. You can assign a new value. You cannot actually edit the string directly. So the idea that strings are immutable is just a little bit confusing, so I wanted to explain what that means for your programs. I'm bringing up our snowfall program again as an example here. And if you remember, when I run it, it's got to save the program. When I run it, it creates a dialog box that has a title, weather warning, and it's got a message. So notice though that I've changed the code now. I'll dismiss this. I've changed the code so that dialog title is now a string that I create up here, a string object that I create up here, and I put the words weather warning into it. So when I run it, I get the weather warning. Here it is. Stay safe in the winter weather. The title is weather warning. That goes away. Okay, so I've commented out a line of code here. Notice that this is something that programmers do all the time. You can use it as a strategy sometimes when you're testing your code or trying to do different things. Instead of using comments as a way to document your code, sometimes you can use comments as a way to remove a line so that the compiler will ignore it while you're trying to do other things. So I set up this example earlier, and I wanted to do something with the dialog title, but for that first run, in order to show you how the program worked, I didn't want it to use this line, so I commented it out, and the compiler ignored it. Okay. Well, now I want it back in, so I'm going to remove the comment markers, the comment punctuation there, and now we've got, after creating the dialog title string and assigning into it weather warning, I create a new string literal called new title, and now I'm assigning that to the string object dialog title. Or is that really what's happening? I said that strings were immutable, so is it actually possible for me to change this string? Let me just run it to see what happens. Does it still say weather warning in the title? It's going to remind me to save. Nope, now it says new title in the title. So it did change. So how is that immutable then? Okay, well, again, I need to explain carefully what's going on here. We did not change the string weather warning. Instead, we replaced the string. What does that mean? It means that the string dialog title was pointing, or I should say the variable dialog title was pointing to an address where the string weather warning was. And what I then did was I created a new string called new title, and I told it to point the variable to the location using the address where this new string was. Going back to this representation, so dialog title originally pointed to something that said weather warning, or winter, what was it? Weather warning, okay, a string object. I didn't replace the words weather warning in the string object. I created a new string object, and then the address actually changed to point to a new string object. So here I've just kind of illustrated, I've tried to illustrate what happened. So dialog title was a string that contained an address that used to point to, I should say dialog title is a variable of type string that contained an address that pointed to a string object that said weather warning. The new title was a string literal. It was still a string, and when we made the assignment, we actually broke the connection between dialog title and the string object that said weather warning, and we pointed it at the string literal, which was new title. So now when you ask for dialog title, you're going to get this string called that says new title instead of that weather warning. So this kind of may raise a question in your mind. If we break this connection to the old string, like weather warning, what happens to it? Where does it go? Well, actually, that's kind of a good question. It actually becomes garbage. Once we change this association, we no longer have a way to refer to that old string, and it kind of disappears from our program, and it actually is taking up space until the Java virtual machine actually, if it can detect that we are no longer using that string anymore, it cleans it up by blanking it out. That's called garbage collection in the programming world. But the important thing here is that when we reassign this address, that we basically point the address from one thing to a new thing. When we use that in our program, here, this string replaces this string. It doesn't change it, it replaces it, and now we have this as a title for our dialog box. So that's the sense in which strings are immutable. So even though they're immutable, it doesn't mean that you can't use different strings, or you can't use a variable more than once to refer to new strings. And it also doesn't mean you can't manipulate strings. You can, through the concatenation operator, as we saw earlier, you can combine strings to make a new string. And if you look at the reference for details about how strings can be manipulated, you'll see that there are a lot of other things that you can do to strings. You can search for substrings, you can split strings apart, you can get information about what's in a string. There are ways to reinterpret a string as a number. If a string contains numeric data, you can treat it like an integer sometimes. Well, not treat it like an integer, but you can get that integer data out so that you can do math on it, for example, because a string with the digits 4, 5 in them is different from the actual integer 4, 5. And here we see an illustration of that. I've created a string that's called not an actual number, and it's the string 4, 5 in quotes. And I've created an int that it is an actual number, and it's got the value of 45, and I've created another int, just other number for illustration purposes, and it's 3. So let's do some arithmetic here. What if we want to add 3 to 445 and see what we get? I'm going to store it in other number. Actually, so I'm going to actually put a new value into other number. But what if I want to say not an actual number, okay, plus 3, and assign that into other number? As you can see, we already have an error here. The Java or the Eclipse IDE is telling us that we have a type mismatch, cannot convert from string to int. So what's going on here is it's interpreting this as this is a string, because it's not the value 45, it's the characters 4 and 5 in a string. It's trying to concatenate that with 3, which actually works. If we system.out.println that, what would it show us? Actually, you can think about that. If this creates a string, what would that string be? Answer that for yourself. But what we wanted it to do was add 45 to 3 and assign it into this integer, into this int, and it won't do that for us. We would have to use an actual number, and now our error goes away. What happens if we put the 3 first? 3 plus not an actual number. We get the same problem. So even though we put the int first, it still thinks we're trying to concatenate, because it cannot do integer arithmetic on a string. So it tries to interpret this in the most, I would say, in a way that works. Okay, so even though you can't add a string to an int mathematically, you can always concatenate those things. So because you can concatenate those things, the compiler says, well, that's probably what you're trying to do. So it does what it thinks that you must be trying to do here. But then when you try to assign it into an int, it tells you, nah, now you've done something that doesn't make sense. There's a couple of things going on here, and it cannot reconcile them, so it just tells you, you know what, you fix it. If we wanted to just print this out, this is what that looks like. Print it to the console. So treat it like a string. We can see what we get. It's going to save it. It just puts the 3 in the front, and we get 3, 4, 5, which of course is not arithmetic, but it does something. So obviously it's important not just that our programs compile, but that they do what we want. We change this with an an actual number, we get something very different. Even though we have something that begins by looking somewhat similar, when we run this, we get actual arithmetic. See the 45 down there. I'm going to finish up this video with some examples and some details about how system.out.printf works. Printf is used to format output, numeric and string output. And I'm going to go through it here fairly quickly, just touching on a couple of points and giving you an example, because there are a lot of options in the way printf works. And you're probably not going to memorize all the options. I never remember them. I always have to look at references, and I'll give you some references to look to for the details about how this works. But it is important to get the basics down so that you understand what printf does in case you need it. So I'm just going to quickly talk about that, show you where to go to get some to look at all the options, and I'm going to suggest that you just play with it a little bit. Like a lot of things in Java, it really will make more sense to you if you play with it and look at the different variations in the options that you have. So mainly printf is used for formatted console output, which means when you're combining strings and numbers and things, often you want to format the numbers, format things so that certain things line up so that it looks nice. It has white space in certain places. It's readable. Okay, and the general form is that you've got a call system.out.printf just like this, and the two arguments, or at least two arguments that will appear in this method call are, it's going to always start out with a string that's called the format string, and then there's a list of arguments that are the variables or values that are going to be kind of shoved into that string at various places to produce the nicely formatted output string that you eventually want. In a very simple example, it's easy to see kind of how it works. It works very much like a system out print line. So you can see system.out.printf. I love Java programming. There's your format string. It actually has a new line character in it. This /n tells the console to go to the next line. You're going to see that over and over. And then the string ends. That's your format string. And in fact, in this case, there's no argument list for values to be put in the string. And that's the simplest case. However, in a more complex case, you actually have numbers or values that you want to place inside of the format string. So, for example, we have an int here that's hours, value is 40, and in this system.out.printf statement, our format string tells us I worked %d hours this week, and then there's a new line. Okay, and then our argument list is just the variable containing the value of hours here. So %d is a pair of symbols here that tell us that we want like a decimal number, not a decimal point number, but a number here that will be inserted into the string at that point when it's output. And %d always applies to a decimal integer. So that could be a byte, a short, an int, or a long. Obviously, we work a lot with ints in this class, so let's just say that for this case, it's for putting an int in this string. And so when this line is executed by your program, it looks like this. I worked 40 hours this week. It just substitutes the 40 for this %d. And since there's a space before and a space after the %d, you get a space before the 40 and a space after the 40, and it looks nice. Okay. So the question is, why not just put the 40 in there? Why not just put plus, use concatenation? Well, because in some cases, in some programs, you might want to display that number in a very specific way, and because the value of the number changes, you can't be sure how many spaces it's going to take up once you run the code. It's much more easy to see in other examples. So here's just an example where you have more arguments in the argument lists. So we have %d dogs and %d cats. So it's %d in both cases because it's telling us that we're going to insert a decimal integer in there. And there's a new line that tells the console to go to the next line once it prints this out. And then our arguments are dogs and cats, which have values, which is good. So it's going to just insert 2 there and 4 there, and that's what the output looks like. You can have as many of those values as you want in your argument list. It's just going to put them in there, just like the format string specifies. So you can see that this thing scales to however you want. But now here we start to see why it's actually useful to have formatted output rather than just concatenating the numbers together with the parts of our string. In this case, we have an int that's a number, and in this case it's been set to 9. Since it's a variable, it could be changed though, but right now it's 9, and we are inserting it into this string. But now we have something a little bit different. %6d, not just %d, and then a new line, and then our arguments. What does the 6 mean? Well, the 6 in this case means it tells the printf statement, it tells this output function to leave 6 spaces for this field. And if the number is shorter than 6 spaces, it's going to be right justified. That's what it does by default. I just noticed that there's an error on this slide. Do you see what it is? Okay, so the description of how printf works is that it's going to leave 6 spaces for this number to be printed in. This number takes up 1 space because it's a single digit number. So if it's going to leave 6 spaces for this number, then that number should actually be in the 6th space here. So it should have 5 leading spaces, and then it should be there. So that's a problem with the slide that came with the book, but that's fine. We can adjust, and we can actually see that this is the way it works, because if we look here, we see a slightly more complicated example where we're now leaving 7 spaces for each number that's placed into the output for the console. And we actually start to see now why this can be a useful thing. Like, why would we want a set number of spaces? Well, if we're allowing 7 spaces, so look at this, let's look at the format here. We've got a bunch of values here, just a num1 through num6. And the output format string looks like this. %7 leaves 7 spaces for a decimal number, and then an additional space, and then leaves 7 more spaces for another decimal number, and then new line. So how this works is it leaves 7 spaces, right justifies the number, and then leaves 7, then it adds a space, it always adds a space, and then it leaves 7 spaces for the next number. So no matter how many digits there are in these numbers, they're always going to be right justified to this spot, to a spot that's 7 spaces long, and it will kind of adjust on the left with enough spaces so that the total number of spaces is 7. And when you do that, you're able to create columns like this, which is really useful in console output if you're outputting a bunch of numbers and you want a table or something like that. So you can kind of see how this would be useful not just with integer values but with floating point values. Because with floating point values, if you have a column of values that you wanted to, say, add together or do something else, generally when we create columns of these values, we like the decimal points to line up. So there's a floating point symbol for printf that is %f that also allows us to do floating point decimal formatting. And just as with the case of the decimal, the integer decimal format printf symbol, you can give a you can specify how many spaces will be allowed for kind of the field that this will be printed into, that the floating point number will be printed into. Additionally, in floating point numbers, since you have numbers before and after the decimal point, you can use this type of structure in your format string to specify that you want 8 spaces allowed for the entire number, but you want 2 of those spaces to be reserved for the decimal, the digits to the right of the decimal point. And that looks like this. So a total of 8 spaces, and make 2 of those to the right of the decimal point. So if you can imagine, if you had a bunch of numbers that were printed out in basically one line after the other, if you're always ensuring that there's just going to be 2 spaces for your decimal points, then the decimal points would line up. And they would always be the same distance from the rest of the string as long as the total was less than 8 characters. So quickly, to see some of this in practice, I've got a program here, and I've already run it to show you what the output looks like, that has a bunch of ints, and it's got a slightly complicated format string for the printfs, and then it outputs all the values. So an additional feature that printf has is it can left justify the numbers rather than right justify them, and that's what's happened here. I've used the character minus in these format strings to left justify these numbers. I've given them each 8 spaces in which to print the number, so I've given them room for 8 digits each, and then I've told it to print them all the way to the left. And this is the output you get. You get columns of numbers that are justified on the left. So this is why I say it's good to play around with these things. You can actually, you could do this. Go ahead and remove the minus signs, which specify left justification, save it, and run it. And basically, now you have the default behavior of right justification with the same numbers. I could also, put an additional space between them. You get a slightly different output. There's an additional space. I could not only space, but I could put like a dash as a divider between these. So as you play with it, you see that the kind of flexibility that you have. Notice that the divider dash doesn't appear just in the middle, but this thing says leave 8 spaces, print this thing right justified, then a space, then a dash, then a space, and then 8 spaces, and it's right justified. So all these spaces are going to be padded to the left of the right justified number. So now I've changed this program to use doubles instead of ints. So I've had to change the format string of the printfs so that they use floats, floating point values instead of ints. So what do I have here? I've got this essentially the same format, except I've got floating point values instead of ints. So let's run it and see what happens there. And what happened is that because of the way it normally prints out doubles, it kind of is a mess because we're getting many more than 8 spaces. We're getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this case, 10 characters for this one double value. And so it's with doubles that you really start to see why people would want to use formatted input, because of the because of the kind of the default behavior is a little bit messy. I'm going to make some of these. I'm actually going to make some of these, give them decimal values, run it again. It's still a mess, but now you have some values on the right of the decimal point now. But if we wanted them to line up, then we would need them to actually control the amount of We need to give them much more space, so 8 is not enough characters to print them out like this, but we don't need to see all those zeros anyway. So let's format them by giving them only space for 2 decimal places. So remember, it's taking these 2 decimal places out of the total of 8 spaces for each. And now what's going to happen if I run this program? Let's save it and let's see. And what we get is we get columns where the decimal points line up, and we were only given 2 decimal places no matter what is in that space. We could even specify only 1 decimal place. In that case, we have some significant digits that are actually in these numbers at the hundredths place, but we're not going to see those if we format it this way. And that's the behavior we asked for. We're going to get the behavior that we asked for, which was to only show up to the tenths place in our output. And in a nutshell, that's how printf works. I will give you a link to a kind of a cheat sheet on printf. I would suggest that if you want to understand this better, you should just take one of the example programs like this from the book, type it into Eclipse, and then mess with these different values, just like I'm messing with them here in the video. It's really the best way to get a feel for it. I don't expect you to memorize how printf works. At least I don't expect you to memorize exactly the format for each of these things. What I do expect is that you recognize printf, that you're able to look up how to do some of these different things, so that if you need it in a project in the future, you'll be able to actually do some formatted output by using the references at your disposal. If you have any questions, as always, you can ask me in class. You can also come to office hours, and emails are also welcome on these questions.